Everybody has a different idea of what makes the perfect keyboard, which is what makes designing one that everyone loves so hard. In this video, I set out to answer one question. Can I design a custom mechanical keyboard that's more than just a prototype, more than just a one-off, but a real product? Can I design a keyboard that not only checks everyone's boxes, but is actually customizable and, more importantly, manufacturable? Well, I may be biased, but I think I f***ing nailed it. As always, the first step in designing a keyboard is the layout. But in order to really knock this design out of the park, I first want to take a look at my previous two designs to pick out my favorite and least favorite features. So my first keyboard was a standard layout with tons of extra macro keys and a pretty nice OLED display. However, I chose a pretty unfortunate numpad layout, so I didn't have any dedicated arrow keys. Then for my split keyboard, I went with a columnar staggered layout with thumb clusters, arrow keys tucked neatly beneath my right palm, per key RGB lighting, and 2.2-inch LCDs. It also had a modular numpad that could be attached to either side. In the end, I loved everything about this keyboard, except for the fact that it was split. Now, having a split keyboard is really nice, but not all the time. It makes it really hard to type with one hand, which, as anyone with a clingy toddler knows, is something I have to do fairly often. I also have 20 years worth of muscle memory built up in the standard QWERTY layout. So for this design, I think I'm going to go back to the QWERTY layout like my first keyboard, but with a couple key changes. But there's no point making a custom keyboard unless you're going to make it unique in some way. Otherwise, you might as well pick a kit you like and customize it by choosing the keycaps and switches you want. So as I was taking stock of my favorite and least favorite features of each keyboard, the first thing that really pops out to me is this giant waste of, well, space. See what I did there? QWERTY keyboards are notoriously pinky heavy, and humans are really good with our thumbs. So I want to capitalize on that by replacing the single spacebar with a set of thumb clusters. Now you have to try not to go too crazy during the layout designing phase because you have to keep in mind the keycaps you want to use. There are services where you can order custom text or graphics on your keycaps, but you're limited to the standard sets. I like to buy blank keycaps so that I can have a little more freedom in terms of where I put each one, but I gotta admit sometimes I can't remember where the hell some of the keys are. This layout is pretty much your standard ANSI 104, but the big ticket items for me were the thumb clusters and arrow keys tucked beneath my right palm. With those in place, I was able to repurpose a lot of the keys along the bottom row in this sort of central column to fill in the extra space around the bottom. And of course I slapped on a full standard numpad, but I made sure to align it with the bottom row, leaving this nice little space at the top, which I'll fill in later. At this point, I was pretty sure I had the keyboard layout how I wanted it, but before I move on, I always make sure to 3D print some test plates so I can actually get my hands on it and feel it. I ended up doing several different versions with just some slight changes, but they only take about an hour to print, so they saved me tons of time and money, not having to reorder PCBs that only needed some slight tweaking. Anyways, once I was certain I had the layout perfected, the real work begins. To actually make a keyboard, I need a PCB, and I like to design my PCBs in KiCad. I have a set of template projects that admittedly could probably use an update, but in any case they make it really easy for me to quickly spin up a new design. In the interest of making this board as customizable as possible, I wanted to support more than one type of switch. To do that, I could either design two separate PCBs entirely, or I could create a new footprint that combines the MX hot swap socket with the KS33 hot swap socket. And that's exactly what I did. Now I know it looks a little funky, but I promise it works because I'm making this video in the future where I've actually tested it. One thing to note is that this doesn't allow you to switch between the KS33 and MX switches willy-nilly because you have to actually solder the hot swap sockets on. So you do have to choose which one you want when you're building the board. But the benefit is that if I'm successful and I'm able to actually sell this as a kit, I can support the MX profile crowd and the low profile crowd with a single PCB design. So with my new footprints made, I can go ahead and place all the switches and wire them up with their diodes. To make the layout part easier, I always make sure to renumber all the components to increment from left to right and top to bottom. This board is going to have per key LEDs, so I also added all the symbols for those. I like the SK6812 Mini undermount LEDs, because that way all the soldering is done on only the bottom side of the board. I wish I had time to get into all the details that go into designing a keyboard PCB, but I got a lot of stuff to get through, so in the interest of time, I'll just link all the resources I use to learn this stuff down in the description. With all the switches and LEDs added to my schematic, I'm almost ready to run the KB Placer plugin. But first, I always make sure to go back and add the component number as an annotation on the front center legend for each key, so that the plugin knows where I want each key to go. With that done, I can download the JSON and run the plugin to see my PCB come to life. The nice thing about this plugin is that I can tell it to place additional components beyond the switches and their corresponding diodes, which means I can have it place the LEDs and capacitors as well. It might take a little tweaking to get them laid out exactly how I want them, so I usually uncheck the option to route with switches until I'm done messing around with it. Then I run it one final time and it'll connect the diodes and the switches for me. At this point, I have all the switches, diodes, LEDs, and capacitors in place, so I can get started adding some brains and other fun features to this PCB. I chose to use the STM32G474RETX MCU, which I know is just a bunch of numbers that you probably don't even care about, but I mention it because this really is a massively overpowered MCU for most keyboard applications. But I needed the extra pins, and I wanted the extra flash memory for the 2.2-inch LCD. Remember that little LCD-shaped space I left at the top right of my keyboard? Yeah, well, that's where it's going. That also gives me a really convenient spot to stick the MCU and all of its components. Speaking of the MCU components, normally you need a USB-C input with ESD and reverse polarity protection and a fuse, and I initially added all those things to this build, but I decided to switch to something better. One of the things I always struggle with is the USB placement. It's hard to get the port in the exact spot you want it while also having it protrude enough for a cable to connect to it through a case. That's why for this build, I opted to use a unified daughter board instead. The UDB not only allows me to place the USB port pretty much wherever I want it in the case, but it also provides all the other protections I mentioned earlier for free. Well, not for free, but you get the idea. I picked up one of these S-Series UDBs, which means all I have to do is slap a Molex Pico EasyMate connector onto my PCB and wire it up to the 5V, ground, and MCU data lines. Now my PCB should be protected from most common electrical issues, and I know they definitely did a better job of it than I would have, so it's a win-win. So after placing the display, routing everything together, doing a little bit of cleanup, and finalizing the board outline, I'm finally ready to order my PCBs. And there's no better way to do it than with today's video sponsor, PCBWay. I've been working with PCBWay for several years now, and I have yet to be disappointed. They've been a fantastic partner, not just in supporting my work here, but also in consistently delivering high-quality boards for all sorts of projects, from simple prototyping to more complex multi-layer builds like this one. If you've never used them before, PCBWay offers a ton of services beyond standard PCB fabrication. You can get assembly, flex, and rigid flex PCBs, even CNC machining and 3D printing, all in one place. Their turnaround times are fast, the pricing is super reasonable, and I've always found their support to be responsive and easy to work with. So if you're thinking about getting your own keyboard design made or any other electronics project, make sure to check them out using the link in the description to get $5 off your first order. Thanks again to PCBWay for sponsoring this video and for making this project possible by providing these flawless PCBs. PCBs that I, since I'm cheap, now have to assemble. I wish I had better footage of the actual soldering process, but not only do I not have the right lens for that, I'm also just not great at soldering, so I'd rather not show it off in high definition. The soldering went better overall this time around, but I chose to skip the PCB stencil in an effort to save money again, so I had to drop a dot of solder paste onto every single pad, which really sucks. But in the grand scheme of bringing a product into the world, I'm like here. So I'm still technically designing a prototype, and I don't have a bottomless bank account, so I try to save money where I can. Like I said before, you have to pick if you want to go with the low-profile KS33 sockets or the standard MX sockets when you assemble the board. There's a much wider range of keycaps that fit standard MX switches, so for this build I went that route, but for either case the process is pretty much the same. Solder on your diodes, LEDs, capacitors for your LEDs, your MCU and its various support components, all the hot swap sockets, the Pico EasyMate connector for the unified daughter board, and finally the LCD. Now this is when I start to get really restless to plug it in and test it out. And I guess that makes sense because I don't want to waste a bunch of time designing a case for a PCB that doesn't work. So I slapped together a super simple firmware build, and to my absolute horror, no, I'm just kidding, it worked great. I'll talk more about the firmware later, so for now let's talk about the case. Designing the case is hard because I don't want it to cost a ton to manufacture, and I want people to be able to customize certain aspects of it. The case is broken up into basically three main components. It's got the bottom, the top, and the plate, as well as the PCB and the unified daughter board, obviously. The plate is what's called gasket mounted, which means it doesn't rest on any hard surface, nor is it screwed in place. It simply gets sandwiched between several sets of these small pour-on foam gaskets. The PCB itself is physically attached to the plate, with some standoffs. Between them is some more pour-on foam, this time a 3mm sheet. This is often called the plate foam, and its main purpose is again to achieve better acoustics. I was going to add some silicone below the PCB to further improve the acoustics, but I decided to hold off on that until I've tested the finished keyboard to see if it's necessary or not. A couple other details that might be worth mentioning: I added a cutout for the unified daughter board and some slots on the bottom for some silicone feet to keep it from sliding around on your desk. So for now I'm going to be 3D printing the main body, but it's too big for any of my printers, so I had to split it up into 2 halves. That leaves a pretty ugly seam, but I have to keep telling myself this is just a very early prototype. I also changed the mounting holes on the top of the case to be able to take some heat set inserts, but eventually I'd like to make it out of aluminum so the holes could just be threaded. I made the plate out of 1.5mm thick acrylic, which honestly isn't a bad choice. It's nice and flexible, which makes for a really soft and quiet typing experience, and it's super easy for me to machine with my CO2 laser. I also cut the plate foam and the little gaskets on my laser, but even though it's supposedly safe with proper ventilation, it's still pretty stinky, and it leaves the edges covered in this sticky black residue that isn't ideal when the keyboard you're building is entirely white. Now, as usual, I completely nailed the design the first time, and I didn't have to print 100 different versions, so with all the parts finalized, I can start putting it all together. Since for now the case is 3D printed, I decided to add some holes along the seam for some 5mm rods to hopefully add a little bit of strength to the glue joint. I couldn't really do that for the top of the case, but it's not really structural, so some super glue should hold just fine. I also added a dab of super glue to each of the gasket slots since the adhesive they come with isn't very strong. For the standoffs that mount the PCB to the plate, it's incredibly hard to find 3mm long ones, so instead I ordered 6mm long nylon ones and cut them in half with a razor blade. Then, after placing the 3mm foam, I used a couple flathead M2 bolts to mount the plate and the PCB together. So with those two things assembled together, I could move on to the unified daughter board, and to make it easier to install or remove it, I added some M3 heatset inserts here as well. Once the UDB was installed, I could wire it up to the PCB and drop the plate into its place on the gaskets. I haven't had time to design a low-profile version of this case to work with the KS33 switches yet, so for now the case is specific to MX profile switches. However, I do tend to prefer a lower profile keyboard, so I did my best to bring the overall height of this build down, and I was able to get the front down to about 17mm and the back to about 28mm. But I'm actually using this keyboard while I'm making this video, and I can tell you I'm really excited to build the low-profile version as well. I've got 4 more PCBs, so I'll likely make a couple variations just to mess around with. Alright, before I show you the final product, let's quickly talk about the firmware. I wrote the firmware in QMK, and since this isn't a split keyboard, it's actually fairly simple and it's extremely customizable, but what makes it a little bit harder is the display. It's not hard to put text or graphics on the display, but since this keyboard has several dedicated macro keys, and I chose to use blank keycaps, I'd really like a way to see what each key does on the display. However, there's not really a great way to do this programmatically. I can make custom keymap images and compile them, but they'll be unique to my keyboard. If someone wanted these keys to do something else, they'd have to compile their own keymaps into the firmware. I did add the current caps lock, layer, and RGB animations as well, but you'll have to let me know down in the comments what else you'd like to see on the display. Anyways, I've left you hanging for long enough now. It's time to show you the finished product. This is Project Mist, a full-size keyboard with a 2.2-inch LCD, per key RGB lighting, a gasket-mounted plate system, and a reimagined bottom row, replacing the boring old spacebar with a thumb cluster for each hand, 10 new macro keys, and arrow keys tucked neatly beneath the right palm. This build has an acrylic plate paired with 3mm plate foam and Gateron milky yellow switches for a smooth and creamy typing experience. Now obviously, I still have a long way to go before this design is ready to sell. It's nowhere near perfect, and in fact most of this keyboard was designed and assembled with a baby strapped to my chest. But I still want to know if this project is worth pursuing as an actual product, so I'll have a comment pinned down below, and if this is a keyboard that you would actually want to buy, either like or respond to that comment. That way, once I've got all the design wrinkles ironed out, I can see if it's worth putting together a production run. Also, let me know what other materials you'd like to see the plate or case to be made out of so I can get some extra prototypes put together. Lastly, make sure to check out PCBWay for all your PCB manufacturing needs, and use the code MODHOB or the link in the description to get $5 off your first order. So, at the beginning of this video, I set out to design a keyboard that everybody loves. How'd I do?